So, okay, let us start a lesson. I thought that it's also a good idea to see how GeoGebra works with complex numbers, and then we go back to the new, actually we go on the board and do the lesson. So I think it is doable with GeoGebra. So you remember I talked about multiplication, division, addition, and subtraction, things like that with complex numbers. Let us try to do something here on GeoGebra as well. So let me just first test. I think I is reserved for that. So there is no I here. Is there? No, I think we just type I and hope for the best, yes? So for example, if I write 1 plus I, yes, it interprets it like, let me just multiply it by 1 minus I. What is the answer? Oh, it understands that this is 0I. That's not good, is it? So what is this written here? So GeoGebra is actually acting very weird. So it understands that this is a complex number. Ah, that's correct. So it is actually doing it correct. It is writing 2 plus 0I. It means 2. Why is that to be 2? Because that is the conjugate rule. So this becomes 1 minus I squared. But what is I squared? I squared is -1, so 1 minus minus 1 becomes 2. But you know that when you want to write a complex number, you have to write it as a real part plus the imaginary part, in principle. So let me just test the idea with division. 1 plus I, and then I divide it by 1 minus I. What the answer is? Let us calculate. It's just I. Is that right? I don't know why it put equal. Why do you think it's the same thing? Okay, but then it corrects it itself when I go to the next line. So do you expect that this number be I? Let us do it on the board, yes? This is the repetition of what we learned. Let me just review this. So if I want to calculate 1 plus I over 1 minus I am dividing two complex numbers. What was the rule? Do you remember? If you want to divide, you need to write it as a standard complex number. It's not a standard one because I also appears in the denominator. So the rule that you need to remember and do it every time, you multiply by the conjugate of the denominator. So this becomes 1 plus I divided by 1 plus I, and then you start multiplying. So this one multiplied by itself is in principle that number to power 2, and this is the conjugate rule. Yes? But this one, if I raise it to power 2, it's 1 plus 2 times the first one times the second one plus the second one squared. And the denominator is what? 1 plus 1, because I squared is -1. But what is I squared again? I squared is -1, so that's cancelled. So the numerator I have 2I, the denominator I have 2. So then you see that the answer provided by GeoGebra is actually correct. So this shows that letter I in GeoGebra is reserved for the complex number. So you don't need to define what I is, you just use it. Okay, but now let us go to this new lesson that I want to talk about, higher degree equations, method of long division. So before doing that, let me give you another example, which I saw it is good in the book. Let me see. And then we go to this topic. So we want to solve equations, but this time let me give this equation. Yes, z squared plus 6iz, and then minus 13 is equal to 0. Yeah, we solve this equation. It's a good starting point because the topic today is higher degree equations. This is the second degree equation. We want to discuss to see if the degree goes higher, is there a systematic way to approach the problem? Okay, but before doing this today, let us just review what we did before. So immediately you realize that that's a quadratic equation, and then 1 is a. So a in this problem is 1. If I ask you what b is, 6i is b, and what c is minus 13. And then you can use ABC formula to solve the problem. So z becomes equal to minus b plus or minus b squared minus 4 times a times c, and then divided by 2 times a. So that's just a standard ABC formula, but I have to manipulate this a little bit so it becomes minus 6i. 6i squared becomes 36i squared, but I squared is negative 1, so this becomes negative 36, and then this becomes positive 52. And then divide by 2. So this becomes 16. Square root of 16 is 4. So it becomes minus 6 plus or minus 6i plus or minus 4 divided by 2. And I can factor a 2 out here. Let me write this one first. So it becomes plus or minus 2. And this is minus 3i divided by 2. So these 2's are cancelled. So what is left for me? There are 2 answers for z, plus or minus 2 minus 3i. There are 2 answers for this. So that's also a good review. Okay, now let me start. So we want to leave the complex numbers and go back to the real numbers for the time being. So let me, for example, ask you, how can we solve this third degree equation? So give me so for example, if I give you x to the power of 3 plus 3 minus x squared, yes. Okay, so let me make it minus 3 so that it works. So x is x cubed minus x squared, that's correct, minus 3x plus 3, okay. Okay, something like this. If I ask you to solve that one, it's a degree 3 equation, and usually there is no standard way to solve those equations. And by the way, a Norwegian mathematician Abel has shown that there is no closed formula if you want to solve a degree 5 equation onward. So you cannot find that. But of course, for the third degree, there is a formula. It's called Cardano's formula. And then for the fourth degree equations, you can also write a formula. But it has shown that for the fifth degree onward, there are no general solutions. It doesn't mean that we cannot solve fifth degree equations. For example, this simple equation, x to the power of 5 minus 1 equals to 0, is a fifth degree equation, and we can solve it easily, yes? I move it to the right hand side, so then I say that x is equal to 1, for example. Okay, so it doesn't mean that we cannot solve high degree equations, but there is no systematic way, there is no closed formula like ABC formula that you can apply and find the solutions, yes? And then mathematician Abel, actually Norwegian mathematician showed that this is not in general possible to come up with a formula so that we can answer all, we can find the solutions of all degree polynomial equations of any degrees. So it is possible for first degrees, second degrees, the third degrees, fourth degrees, but there is no general formula if the degree is 5 onwards. So the only thing we can do is to factorize, if we can solve it. So if we can factorize this polynomial, then we can actually, in principle, solve it. But factorization is also not something easy. So we need to practice a lot to be able to factorize, but that is not goal of this lesson. The goal of this lesson is that they provide you with an extra information. For example, they say that show that x equals to 1 is a solution. Using this piece of information, they ask you to find other solutions if there are other solutions as well. Okay, so this is the generic example that I want you to have in mind. So they don't usually ask you to solve this equation if the degree is more than 2. They design the question usually like this. So they say example. show that, now let me write like this. Consider the equation, that equation that I have written there. Consider the equation this one. Part 1, show that x equals to say 1 is a solution. They always give you, not because checking this is hard, because they want you to use this as a guide to solve the harder part. Number 2, determine, if any, determine all other solutions, if any, let me write all other real solutions, if any, for this equation. Okay, so let us try to understand this problem. That's the lesson for today. The first part is actually very simple. So what you do, you replace x in the equation with the number proposed to you, which is 1. So number 1, I would say that the left-hand side of my equation, when I replace x with 1, is 1 to the third minus 1 squared, and then minus 3 times 1 plus 3. But if you calculate that, this becomes 1 minus 1 minus 3 plus 3, which is indeed 0, and that is equal to the right-hand side. So it is confirmed that, yes, x equals to 1 is indeed the solution. But how can I exploit this piece of information to find other roots of that equation if possible? Okay? This is the method of long division that I want to teach you today. Okay, so, but what is the idea? The idea is that when I consider this polynomial, p of x, exactly that polynomial in the equation, and I know that p of 1 is what? 0. Yes, because I myself replaced, according to the guide in the problem, x with 1, I realized that the answer becomes 0. So if I introduce p of x to be this polynomial, and if I ask you what is p of 1, you do the same thing. You replace x with 1 and calculate, but when you calculate, it becomes 0. So, but can you tell me, of course, if I ask you factorize this, might be you don't know how to factorize, but it's something you know. One of the factors of this polynomial you need to know. Do you know that? Because you say that if p of x, I factorize it, I don't know, at most 3 factors will be there, because the lowest degree of each factor is 1, and then the degree of this is 3, so at most you factorize it into 3 polynomials of degree 1. Okay? But one of them you can immediately guess what is that one by this information that you now see in front of you. Can you tell me what is one of these factors? Yes?
X minus 1.
Yeah, x minus 1 should be one of these factors, yes? Because you know that p of 1 is 0. So one of these factors should be in a way that p of 1 for that factor should be 0. So if, let me just write this. So if p is a polynomial, p of x is a polynomial, and if p of a is 0, then x minus this number, whatever it is a factor of p of x. So this is the observation that actually it was not hard to tell, because you also told me what is going on. So we know that if I have a polynomial, And when I calculate that polynomial at a number, it turns out to be 0 for some reason. Then I can conclude that if someone succeeds to factorize this, that person will see this factor as one of the factors. Yes, is that right? X minus a. Okay, so then I don't know what is happening here, so I can say that this is multiplied by another polynomial. So let me write q of x. So that is then my goal. I want you to understand. So if you want, I can say that if p of a is 0, then p of x is equal to x minus a multiplied by a qx. If you ask me what qx is, the only information that I can give you, I can tell you that's also a polynomial. Okay? And I can say something about the degree of the polynomial qx. What is the degree of the polynomial qx? No, we don't know. In general, in this case, second. But in general, if the degree of my original polynomial, say it is n, the degree of qx is n minus 1. So it becomes degree of p of x 1 unit less. So this is hopefully, if you understand this thing, we are good. So if I have a polynomial so that p of a number a is 0, that polynomial can be written in a factorized form as x minus a multiplied by another polynomial. The exact form of that polynomial is not clear for us yet, but what we know is that the degree of that polynomial is the degree of my original polynomial minus 1. Okay? Is that clear? Okay. Now, the method of long division tells you how to find qx by a systematic way that I want to describe now. So is the idea clear? Okay, so how should I find that? This is what I want to describe. This is an algorithm, actually. I'm just describing the algorithm, so you need to learn that, okay? So what we do in order to find q of x, which is called the quotient polynomial, I do like this. I think in Swedish books they write it, in American books they write it a little bit differently. So let me just follow your book. Minus 3x plus 3. If I remember that correctly, they write a line like this in your book and something like this. So you put your polynomial here. You put this polynomial that you found by this idea, put it here. And if you follow what I am telling you, you will get your qx on top here. Okay? So how should I find that? This is division. It's called long division. We want to divide this polynomial by that polynomial. So what I do, I take only the first term, and I also take the first term of that one, and I divide only these two. So assume that x2, so you can go to a scratch paper, you can write x squared cubed divided by x. What's the answer? X squared. You put it here. And then you multiply this here, but you write the answers here with the opposite sign. Okay? So I multiply x squared here, it becomes x cubed, but I don't write x cubed, I change the sign. Yes? In other words, I'm subtracting them. You can write with the same sign, but remember to subtract, but from my experience, it's better to change the signs immediately. That's up to you. And then I take x squared and multiply it here. It becomes minus x squared, but I change the sign. And then after this multiplication is finished, I draw a horizontal line and I add this blue polynomial to my original polynomial. So this one and that one are gone. Coincidentally, these two are gone. Two terms are left, I bring them down. And I repeat the process. So I repeat the process means we assume that instead of this black one, this is given from the beginning. And I repeat the process. What does it mean repeating the process? I take the first term here and the first term there. I just divide this. The answer is what? Minus 3. I put minus 3 here. And I multiply minus 3 there. It becomes minus 3x. But I told you I changed the sign. I multiply minus 3 by minus 1. It becomes positive 1. Positive 3, but I change the sign. And then I add them So you continue, you see what is left? 0. Whenever this 0 is left, it means the problem is finalized. And this is your QX that you are looking for. Yes?
Can you explain again how you got the 3 on top? Minus 3.
So when I did this process, I repeat the process again. So I take the first term again,
Yes.
and then the first term, and I divide them, it becomes minus 3.
Okay.
Okay, so that was the QX I was looking for. Of course, this will help you because what is happening, because the degree of QX is less than degree of PX, solving this equation equals to 0 should be in principle simpler than solving this equation equal to 0, because we reduce the degree at least by 1. Of course, this is not always easier than the original one. So if you start with a 5th degree equation, even if you do that, the equation becomes a 4th degree equation. 4th degree equation is simpler than the 5th degree, but we still are in trouble. Yes?
Do not divide by the minus 1 also? Or did you already?
No. You don't need to divide by minus 1. Only first term and first term. Minus 1 plays the role when you multiply.
What if you have a longer polynomial on the right then? It's like x squared minus...
No, again, you take the first one on the first one.
Always
The other terms are actually changing the problem, because when I find that one, I multiply this not only in the first one, but in all of them.
Okay.
And then this will appear here. So, for example, if this minus 1 is positive 2, when I multiply it here, you will see the change here, not in the first division. Okay, so what happens here? And then it means that my polynomial, which is p of x, is now x minus 1, which I was able to guess even without going through this process, but multiplied by qx, which I was not able to guess. I found it using this idea. Yes, so this is my polynomial. It is my factorized form. And then my goal is to solve p of x equals to 0. So this means that instead of solving this 0 directly, I solve this one, which is the factorized form. And then I can use the 0 product rule. The product of two numbers is equal to 0. So either the first one is 0, which gives me 1. Of course, it is not surprising. I knew about this from the beginning. And then I get two new answers. X squared is equal to 3. So this means that x is equal to plus or minus the square root of 3, which I was not able to just guess. Yes? So this means that this problem considered to be a hard problem if you don't have that. It's not hard, by the way. It's not hard to factorize this immediately. But if you are not that experienced in a factor, I just want you to know that if people change it, even I myself get into trouble to factorize, because I just want to say that factorization is not just very easy, okay? But if I get some extra piece of information using this systematic method, I can at least factorize it once. I'm not saying that I fully factorize, but at least I can write it as a product.
Please, how would you factorize this one?
This one is easy because you can just take the first two. Between the first two, I factor x squared.
Yes.
And between the second pair, I factor a minus 3. And then you see that x minus 1 appears. Yes. Yeah? Okay, let me give you another example. For example, the same type of problem. So example, let's consider the equation so x to the power of 3 Consider the equation. Show that, number 1, show that x equals to minus 2 is a solution, is a root to this equation. solve this equation on the complex numbers. When I say solve, I mean find all of the solutions. Solve this equation on the set of complex numbers. Of course, it might happen that all the solutions are real, it doesn't matter. But if in case some solutions are complex numbers, I don't want you to avoid them, I want you to contain them. So, again, the first part is easy. That's actually for guidance rather than having it as a part. Of course, you will get some points doing it, but that is just for your guidance. So I would say that, okay, left hand side is equal to minus 2. I replace every x with minus 2. And then calculate this. So what happens? It becomes minus 8 minus 12 plus 20, which is indeed 0. And that's equal to right hand side, yes? Am I right? Yes. So this is 0. Then what I understand, from part 1, I understand that I would say let p of x be that polynomial, which was introduced in the problem, x to the power of 3, 3x squared plus 20. So we learned that p of minus 2 is 0. Okay, I want you to tell me what should I write. From the information that I processed in the first part, p of minus 2 is 0. So it means that p of x can be written as what? As something multiplied by qx, which of course I don't know yet. Yes? What should I write in?
X plus 2.
X plus 2, yes? Because the answer should be minus 2. So don't get confused. You don't write minus 2. You have to write plus 2. Because when you put it equal to 0, the answer is supposed to be minus 2. Okay, and then for finding this question mark, I told you what to do. You go to the long division method. So let us do the long division here. So what is the long division? I will take my polynomial, which is x to the third minus 3x squared plus 20, and then I divide this by which factor? X plus 2. Okay, let me repeat again. If you haven't learned that one, that's the same process. So what I do, I will take the first term. By the way, I forgot to tell you that you have to write them in standard form. Standard form means that you have to go from the highest power of x to the lowest power, both here and there. Okay, and then you take the first one and the first one only, and you divide it in your head. It is much simple. Yeah, so it's very simple. So what's the answer? X squared, you write it on top. And then you take what you got and multiply it not only for the first, but for all of it, even if you have more terms involved here. So you multiply the first one, it becomes x cubed. You write it here, but with the opposite sign. And then you take x squared and multiply it by 2. It becomes 2x squared positive, but you are supposed to change the sign. Am I right?
Yes.
Yeah. And then you add them. Okay? When you add them, the first one and the first one are cancelled. And then minus 3x squared and minus 2x squared are not cancelled. They are actually added together. So what's the answer? Minus 5x squared, you bring it down. There's also 120 left, unaffected, so you bring it down. Yes?
How did you get minus 2x squared?
I just told you, I take this one, multiply it here and there. But I change the signs. So when I multiply this here, it becomes x cubed. I write negative x cubed. It becomes positive 2x squared. I write minus 2x. And when I add them up, these terms are cancelled. Minus 2x squared and this one are similar. So I add them, it becomes minus 5x squared. There is nothing that I can add to 20. It's alone, so I bring it down. And then repeat the process. That's it. So if you can do it once, you can do it the next time. Yes? So what is the meaning of the next time? It means that I can momentarily forget about everything, assuming that this is given in the beginning. I take the first term here and the first term there, and I divide it. It's easy to divide it in my head. What's the answer? Minus 5x. You put minus 5x here, but you multiply minus 5x here and there, change the signs and put them here. So minus 5x multiplied by x is negative 5x squared, but I told you you are supposed to change the sign. And then you do, and there's another term involved. Multiply it there, it's minus 10x, but I told you are supposed to change the sign. And then add them. So this one and that one are cancelled. It is important to remember not bring 20 first and 10x. You have to respect the order in which the powers are arranged, from the highest power to the lowest power. Technically 20 plus 10x and 10x plus 20 are the same, but for the purpose of this algorithm, you need to bring 10x first and then 20. You need to continue until you reach the remainder 0. Okay, so it means that you need to continue once more. Again, the same process, only the first term and the first term divided in your head. What's the answer? 10. Don't write 10 like this. What should I write? Plus 10. 10 means plus 10. Okay, and then you multiply 10 here and there, change the sign and put them below. So 10 times x, 10x, and then you multiply by a minus sign, change the sign. 10 times 2 is 20, you change the sign. And then you add them. What do you get? 0. Because this has cancelled, this is also cancelled. So this plays the role of your quotient. So the quotient that was missing, now you can go up and then solve the problem. So what is the quotient? You see x squared. So let me write it in this black. Okay. And then what is q of x? What is q of x? The one not on top, yes? So it is x squared
Minus 5x.
plus 10. So I changed my color to black. By the way, why do you think so?
But you changed your color to black.
Is there any point? No?
That's not
The ink in the blue is finishing. Yes, it's simple. Explanation is simple, yes. Okay, so p of x, we want to put it equal to 0. This is why, by the way, you always get the answer which was given to you in the beginning. So that's not the interesting part, because you knew about it even from the beginning. That one which we couldn't guess is the interesting part. But you need to write it properly. So what I do, I would write p of x equals to 0. Then what happens is that x plus 2 and then x squared minus 5x plus 10 is equal to 0. The product of two numbers is equal to 0. So either the first one is 0, which of course not surprisingly give you the answer from the beginning of the problem. I don't know where was it. And or this one is important. And then in this problem, I intentionally solve it in complex numbers, because probably I could guess that the other solutions are complex numbers, but hopefully it will work, okay? So if they say, let me just solve it for you. So the other one we have to solve. They can ask you to solve it on R. They can also ask you to solve it on C. So if you are supposed to solve it on C, no problems. Every solution, even complex numbers, are acceptable. But if you are supposed to solve it on R, you throw the complex numbers away. Okay, but let me solve that one. So x squared minus 5x plus 10 is equal to 0. So I use ABC formula. So x is minus b plus or minus this number squared minus 40. And then divided by 2. So immediately you see that these are complex numbers, yes? Because this is negative. So it becomes 5 plus or minus a square root of minus 15 divided by 2. If I ask you to solve it on R, end of the problem, no solutions. There is only one solution, and that's -2. But now that we are supposed to solve it on C, even though technically speaking that is correct, but you have to write it in terms of I, so that is necessary. So how should I do that? I write it as 5 plus or minus the square root of 15 times I, because I is the square root of -1. And even I don't like it right, because you usually need to write it the standard way. So you write a real part plus or minus the imaginary part. Yes? So these two answers we couldn't guess if we didn't know about the long division method. Okay, so how many, let me just use GeoGebra now. How many, if I draw the graph of this function, which function? X cubed minus 2x squared plus 20. How many intersection points do you expect with the x-axis? Because usually the intersection points with the x-axis are the roots. And if I ask you how many roots are there in the complex number 3 roots, one of them is -2, which is also a complex number. Why -2 is a complex number as well? -2 plus 0i. That's a complex number. Those two are also complex number because they are very clear that you have I. But two of them are complex number. You shouldn't expect to see them when you draw the graph. So there is only one intersection point that you see, and it occurs at -2. It's not bad to check it online on GeoGebra here.
Where is 0i? Where in the graph is it?
No, we will come back to it later because we need to know how to draw how to imagine a complex number as a point in the complex plane. But we haven't reached to that point yet. Okay, so let us see how this will work. If I ask GeoGebra to draw the graph, y is equal to x to the power of 3, yes? What is that? Minus 3x squared, and then what? Plus 20. Unfortunately, this will take us to the moon, yes? Yes. Now, but we come back to Earth by probably rescaling things. Okay, and as you see, there are no intersection points. So there are only one intersection point because graphing is only capable of giving you real solutions, not imaginary solutions. And then I don't know, if we go to CAS view, do you think that the GeoGebra is also capable of solving that equation for us? So if I write x to the solve, I think, might be it will ask you in which domain you want to solve the equation. Solve equation. Okay, I have something. Let me type it with z rather than x. Might be it will automatically understand that we are interested in complex numbers. Plus 20.
It's 3z squared.
Z squared, yes. No, z squared. No, I think it only gives you the real solution. So how should I? So let me. Now I start recording as if I knew it myself. That was good. So listen, my students, if you want to solve using GeoGebra, you need to use complex roots. Okay, so complex root polynomial, let us just do that. Z to power 3 and then minus 3z to 20. But it doesn't give you enter. Ah, yes. But the bad point, it gives you approximate values. Anyway, but that's correct. Because you see that what I got here is 5/2 for the real part, which is exactly 2.5. And that number that you see is this number. And then these are, by the way, these are the graphs. These are the dots of Z1, Z3, and Z4. Yes, we will talk about that. Was what Hussein actually asked. We will come back to that later. But let us also check Wolfram